guys.
Hello!
So we're gonna show you guys some stuff with the Casio, like behind the scenes, how we figured out how to do what we did.
Right, so the first step in reverse engineering this keyboard was to get an idea of what the keyboard matrix map was. And so using the keyboard, this keyboard has 31 keys, and they all feed through 13 lines at the top there where Whisker is showing. And so what I did was I created on graph paper all of the keys from F1, I believe, or F2, all the way to F1 to C4. And we gave them a number 0 through 31 for the different switches, just because it's easier to
0,
count.
1, 2, 3, etc.
Right. And along my Y here, I have those 13 lines that we were pointing at. And so we pretty much just want to see where the different parts of the switches of the keyboard connect to. And all you really need for that is a multimeter and the beepy function. Yep. So we're just going to demonstrate. Whisker's going to show you where we're tapping in, and I'm just going to record what he tells me.
Which switch are you starting with?
0, otherwise F.
Okay, top or bottom of that one?
Top of the switch.
Okay, so top of 0, following this trace up, goes here. That's a jumper, a diode. It looks like a diode because I don't get a beep through it.
Okay.
So I'll move that probe to the other side of the diode, and then 1, 2, 3, 4, 5, 6, pin 6.
So I'll write a little D for diode, and I'll put that as T for top. So the top of the switch connects to pin or line 6. Okay?
Okay, bottom of that switch. B, 1, 2, 3, 4, 5, 6, 7. Pin 7.
Does that go through a diode?
Nope, none of the bottoms do.
Okay. So B for bottom, and I put that from, or line 7, I should say. Okay, let's go to switch 1, top pad.
Okay, the top, following this trace up, connects there. But again, that looks like a diode, so I'm moving my probe to the other side of that diode. 1, pin 1.
Okay. Okay.
Bottom of that switch. 1, 2, 3, 4, 5, 6, 7, 8. Pin 8.
Okay. All right. Switch 3.
3, top goes to there. So we got another diode. 1, 2, pin 2.
Okay, so diode.
Bottom
2.
1, 2, 3, 4, 5, 6, 7, 8.
Okay. Then switch 3.
Top there, diode. 1, 2, 3, 3.
Okay.
Bottom of that one. 1, 2, 3, 4, 5, 6, 7, 8.
Okay. Pin 4.
Switch 4, top, next to there, but that's a jumper, goes right through.
Okay.
Following that along, diode. So jumper, then diode. Move my probe to the other side of the diode. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Check my probe. 1, 2, 3, 4, 4.
Okay. So a jumper, a diode. Okay. And then we'll do the bottom pad for that
Is that 5?
4.
0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8.
Okay. And then 5.
Looking at these are all connected to each other, so 0, 1, 2, 3, 4. Switch 4, the bottom is 8.
Yep.
Switch 5, the bottom is 8. Switch 6, the bottom is 8.
Okay.
0, 1, 2, 3, 4, 5. Top connects to there. Jumper. There's a diode. 1, 2, 3, 4, 5.
Okay, so a jumper, a diode.
1, 2, 3, 4, 5, and we're on 6.
Yep.
6 to there. Jumper. Diode. 1, 2, 3, 4, 5, 6.
Okay, jumper, diode.
6. Okay, so the top of 7 goes to a diode. One.
Oh, 1, okay.
You need the bottom of that.
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
So is that switch 7?
Yep.
Okay, so the bottom of 7, 8, 9, 10, 11, and 12 all connect to the same place.
Okay.
0, 1, 2, 3, 4, 5, 6, 7, 8. Top goes to a diode. 1, 2, pin 2.
Okay.
Top of 9. Diode. 1, 2, 3, pin 3.
Okay.
Top of 10. Diode. 1, 2, 3, 4, pin 4.
Okay.
Top of 11. Diode. 1, 2, 3, 4, 5.
Okay.
11. Diode. 1, 2, 3, 4, 5, 6.
Okay. So as you can see from doing just some simple beepy point-to-point check, we essentially found a pattern of how the top halves of the switches and the bottom halves of the switches work for this keyboard. For all the top halves, you'll notice they have this diagonal pattern on lines 1 through 6, and the bottom halves of the switches have a pattern where 6 keys next to each other are essentially read in on the same bottom line. So you can expect that the next 6 notes would be read through line 10, then 11, then 12, and so on. So this is an easy way to get a keyboard matrix map of your own, and all you need is a multimeter.
Yeah, and this is all we really needed to do to MIDI-fy this particular keyboard in our big project. But we're going to go a little bit deeper than that, so stick around for the next part of this.
ProtoSynth MIDI, ProtoSynth MIDI Lite, and all compatible modules are available for sale at tindy.com/stores/TYMKRS, and in-depth technical information about this and all of our products are available at TYMKRS.com. krs.com.